with technical knowledge that are breaking things down for us. I know that I appreciate it as someone who's non-technical. Up next is the talk that I've been looking forward to all day because it's something that I'm quite passionate about, and it is about what it takes to make zero knowledge consumer ready. I've been working in the ZK space since earlier this year, and the person that we have joining us on stage, Deepthi Kumar, is the co-CEO of O1 Labs. And if you've been around for a while, you know that O1 Labs has played a great role in ZK adoption. So Deepthi, please welcome to the stage. Excited to hear your keynote.
Labs, O1 Labs incubated Mina protocol. Just a quick description about Mina protocol. It's a succinct blockchain. What that means is you verify the entire chain with a single proof. I know it sounds like magic, but it's happening, and it's been happening since 2021. So yeah, today I'm going to talk about something that concerns everyone who is building digital infrastructure. The question is, can we build something that verifies information without creating liability? Right? The answer essentially was no. I mean, you can build like stuff around it, but at the core, it's no until zero-knowledge cryptography came along. So a little bit of background, I guess. Up until now, historically, as well as very prevalent now, for most of history, if anyone wanted to verify something, you would present the underlying data itself to them, and they would look at it. They'd be like, OK, I believe you. Right? That's how verification happens. If you go day-to-day, day-to-day things that you want to get a phone connection, or you want to prove that you're over 18, you show your entire data, and that's how you can prove it. And every single time you do that, well, actually, this worked well when you had just like paper copies, right? You would just go and you like, OK, here's my ID. Someone looks at it, like, OK, good, you're good, and then moves on. Life goes on. But in the sort of digital world, every time someone does that, they essentially keep a copy of your data. And now it's in their systems. They may encrypt it. They may keep it safe. Who knows? But it's in their systems, right? And every time, and this is not just one database. It's every single time you want something and someone needs to verify information, it goes onto their systems. And and each copy is essentially a liability. They need to make sure it's secure and safe. Yeah, and this setup doesn't work at digital. Like, it works for a small scale, maybe in a small village, but the digital scale kind of broke this model, right? And to give some more concrete numbers on this, like, there's reportedly 81.5 crore Aadhaar records are available on dark web, and 14.7 crore Americans' information was exposed during this Equifax breach. So it kind of shows you the intensity of this model that we have now. And it's something we've kind of normalized, right? If digital verification, it's the cost of doing business online. Digital verification, it doesn't forget. It aggregates, it correlates. Your data is all there. You can make correlations. And unfortunately, it also leaks. But ZK kind of broke that assumption, right? And what ZK does, OK, I keep saying ZK, but it's essentially zero-knowledge cryptography. It's a whole field, and there are various types of like primitives and everything that you can use, but I'm kind of very generalizing it as ZK. So if you want to talk to me more deeper, definitely after the talk, you can come to me. But what essentially allows you to do is prove a statement is true without revealing the sensitive data that makes it true, right? So how does this play? Like in the old model, show me a bank statement and to prove that you have a balance. So you're essentially showing your spending pattern, who gives you money, to who you're sending your money, and all of that. But in the ZK model, you just prove this fact, that you have a balance that exceeds some amount X over Y period. Right? Another example. Prove that you're over 18, you're over 21, over 22, which is the drinking age. And what you do is you show your ID card, which has so much more information. And in many scenarios, birth date combined with a few other information gives you access to a lot more private information. So you're kind of exposing an important data. In the ZK model, you give a proof saying I'm over 18, and that's it. And the person has to trust you, because if they trust cryptography. Third example, it's sort of the general example, which is handing over the entire audit trail. Like one specific case is the bank statement, but it could be anything, right? To prove like any compliance, regulatory compliance, or anything, you have to basically show everything. Whereas with the ZK model, you write an application that only gives out the information that you want, or the compliance or regulatory, whoever wants it, you give them. So it's a different paradigm. It's a different way of thinking. It's a different way of writing applications. But it's possible to do this now. The cryptography was kind of always there, but it's become more accessible, and you can build applications. So, there are two main components of this model, and the very important part is who creates the proof. Okay, so you write a zero-knowledge application. Someone has to generate the proof. Someone has to verify the proof. It is very important for the proof creation to happen at the client side, because it's when you create the proof you supply the private information. So if there's a ZK system that's run on some other server, so you're essentially sending over the private information to that server, and you're kind of creating the same liability with some extra steps. Right? So that's not really what we're aiming. So client-side proving is really important. And the flow is essentially like the data is on your local machine, on your phone, laptop, browser, and you generate your proof there, and you only send out the proof itself and the public statement, right? Whatever statement you want to prove, that gets tagged along with the proof, and you send it to whoever wants to verify, they verify it. Or you send it to the chain verifies it. And what you get out of this is that your personal data, sensitive information is never transmitted. There's no honeypot. It's not stored in some central database that hackers can hack and supply. And it's architecturally private, right? There is no question about leaking because it's not leaving your system. So it's very secure in that sense. The next component is verifier. Who verifies it, right? And the proof is only useful as long as someone can verify it. But verification requires access to the blockchain state or the verifier program. There are two ways to do it. You can go the blockchain route, or you have people run the verifier program themselves and verify, and have their own infrastructure to save the proofs, to manage, and everything, which essentially kind of blockchain gives you for free, right? But accessing blockchain state is kind of expensive. Most chain, you need an RPC provider. You need to run your own validator. And this is all assuming you want to do it in a trustless way, right? If there is immense trust, we wouldn't be talking about all these things. So with verification, your trust assumption kind of moves. And most chains, you would want to run trust infrastructure. You trust the infrastructure. You want to run a full node, which takes days to sync. You need to create all of that infrastructure to run it. But also when you combine with multiple zero-knowledge applications, it kind of gets complicated very quickly if you're not able to easily access it. Because transactions kind of get buried deep into the blockchain, and it kind of becomes difficult. And so it's quite important to have very permissionless, accessible verification. So anyone can verify on any device, verify in milliseconds, so the speed is important. No trusted third party, no RPC providers. You're able to access the blockchain state quickly. You can work on phones and browsers, because I think it's important to meet the users at where they are, than asking them to rent a big machine or buy a big machine and take care of their data. So yeah, it's one of the things of this architecture is very appealing to enterprises. Enterprises up until now, have this dilemma that to use blockchain and all the properties that a blockchain gives, institutions that want to use it, they aren't able to, because you kind of essentially expose your data, your proprietary information, your algorithms, your competitive advantage, all of that you may have. That's how generally smart contracts work in traditional blockchains. It's all executed on chain. With ZK, well, you can have two ways, but with ZK, generally, you execute off-chain. You execute it on your machine, on your own private server, your own private infrastructure, and verification happens on-chain. So the information, the data, your business logic, all of that stays private, and the chain kind of verifies the proof. And so anyone in the world can know that you executed it correctly or as per the rules, but won't get any information other than that. So it's verifiable settlement without exposing the terms, the competitive advantage, all of that. It's auditable compliance without revealing data. Generally, the misconception is you hide everything, when you talk about privacy, zero knowledge, but it's selective disclosure. I would share with whoever I want. And it builds public trust without public exposure. And this, I think, makes a lot of sense in sort of the government setting, because you can make that possible while not exposing national sensitive information. Right, OK. So now, what is it that we need to make ZK consumer ready? The first thing I want to say is ZK technology has been around for a while. Only recently is when it's become more accessible. People are able to build applications. But there's still kind of long way to go, because proof generation currently actually is in seconds. It was in minutes, and now it's in seconds. So the advancements are happening pretty quickly. There's a lot of research happening. But we kind of need it to be in sub-seconds in consumer applications, because people shouldn't be knowing, OK, the proof's sort of generating. It has to be very quick. So there's proving time. Similarly, on that vein, device constraints, they kind of have to work on your smartphones, most budget smartphones, if you want to have mass accessibility. Dev experience, I think like I said, it's a different way of writing a program, different way of thinking about it. And so, it's not anymore just cryptographers being able to write zero-knowledge applications. It's much more accessible. There are TypeScript SDKs, Rust SDKs that developers can start building on. The abstractions have been made very simple and easy to understand for everyone to build these applications. User experience, like I said, people shouldn't need to know ZK to be able to use these products, right? So there's a lot of design work that needs to happen about the user flow and around that. Standards, the interoperability. Right now, there are many different proof systems. Proof systems are the one that enable you to generate proofs and verify them. So there are different kinds of proof systems. Different projects have different needs, and based on those needs, there are different proof systems. So we need some sort of interoperability, and not just on the proof system side. It's also on the data that you consume. They need to be in a format that can be consumed. So there's some standardization that's needed there, which is not really there, but there's a proposal in W3C for verifiable credentials. So there's this progress in that direction. Oh, and then, yeah, data sources. So the ZK applications that are on chain, if you want to connect them to real world, then you need to be able to use real world data. So the data sources need to be in a format that can be used and can be reliably used, not just used. So for example, like the DigiLocker thing with Aadhaar allows you, it's a signed message of your identity, and you can use that in your zero-knowledge applications. In fact, we just had a workshop where one of my colleagues was showing you how you can use Aadhaar card. There's a library called Anon Aadhaar, with which you can write applications that selectively disclose certain facts about your identity. So you can already do that right now. So yeah, so privacy is no longer a research problem. It's possible. It's more of an engineering and a design problem. There's still more work that needs to be done, and it is happening for it to be more consumer ready. So some honest assessment about where we are. Proving time, like I said, it's in seconds, but it needs to be faster than that for it to be on mobile applications. So it's workable. It's workable with smaller applications. You can run them on browsers, but as applications kind of get complex, it becomes larger and takes more time for proof generation. So it's still kind of slow on mobiles. Device constraints, similarly, you need to have optimization for certain kinds of device. Developer experience, the ecosystem is maturing in amazing scale. The tooling around the SDKs, TypeScript, Rust, all of these, the development experience and tooling is building up. So it's not like maybe traditional software programming, but it's like I said, it's a different paradigm, and the support system and the tooling for that is being built. User experience, this is one of the biggest things, I think. What does it mean for users to use these kind of applications? How can they use it? How can they be aware of what's being sent, what's not sent, and what's the flow, what's the user flow with various user data? So I think there's lots of design investment that need to be made. And then credential infrastructure. Credential infrastructure is essentially what I said in the previous slide about having data sources that are used, that can be used in the ZK framework. And India actually is ahead of most because of the DigiLocker, but there are many other identities, like your PAN card, your driver's license. If all of these are sort of digitized, then you can make so many proofs, you can make so many statements without revealing whatever is in these cards. And then standards, same thing. There's a proposal now, so it might take a few years for that to mature. So there's a little bit of work there as well. So essentially, the summary is that the cryptography works, and we need to start shipping products that people use, iteratively develop, and make it mainstream. So that's sort of the previous slide was sort of the state, but I want to talk a bit about all of the different areas. Well, this is not all, but 4 different areas where I think it really shines. Finance, obviously, you can have your operations, all financial operations and compliance without surveillance. Essentially, you don't put it on your blockchain because everything is, everyone knows what you're doing. It's your wallet. And the second one is generally ZK enables you to have more robust security practices. mainly because you are not storing any of the private information. Because if you're responsible, which I hope many companies in this world are, they're storing our information, and they need to have really high security practices around the data. But with eligibility checks like these, you minimize that information so you can have better, you don't have as much exposure. Another emerging sort of area is AI and computation. Proving the entire model is super slow, so it's not really practical at this point. But what you can do is prove agent computations. Like if there are AI agents and you want them to, they go about and do their own thing, you have certain confidence that they've executed it as per the ZK application. So there's that possibility. Another very, very important and trending sort of topic right now is proving authenticity, like images generated with AI and not generated, real images. And ZK is something that is very much applicable. We actually at O1 Labs built a proof of concept. You can go and look at the TouchGrass .party website to look at that. We built a proof of concept that verifies real images using ZK. And then this is another area of governance where ZK is very much applicable. You can build a voting system where you keep the voter's identity and what they voted for private, but reliably compute the results and expose only the results. You can have, same thing, eligibility checks without identity exposure. And you could also have subsidy distribution, all sorts of governmental initiatives. You can have them without having these huge beneficiary data. Because every single time you start collecting, you start building databases, you are creating more and more liabilities, more and more problems. And not just for users, for enterprises too, because they're the one who needs to secure them. Yeah, so at the end of it, what's important when you're analyzing ZK systems is two important things. Where does the proof get generated? If it's getting generated on our infrastructure, whoever, their infrastructure, then you're trusting them with your data. If the proof is getting generated on your device, on the user's device, then your private data is with you. Who can verify? If the ZK systems that you're looking at comes and says, trust our infrastructure, we will verify it, then it's not really permissionless. And then if it says anyone or any device can do it, then you've built sort of accountable privacy. And that's something where we, O1 Labs on Mina, are able to say that because the chain is essentially succinct. You can verify the entire chain on a browser. You can run a validator on a browser. And anyone can access the chain and start contributing to the network, right? So it's kind of, it's an important aspect. And I think I want to kind of really emphasize why this is so relevant here, because India built one of the most ambitious digital identity infrastructure. And the next step is not to build more and more databases using that infrastructure. It's using zero-knowledge cryptography to be very efficient and smart about how we use that infrastructure. So yeah, I'm really hoping that this catches up in India and people start writing zero-knowledge applications. So if any of this resonates with you, and all of this is currently possible on Mina, that was my whole build-up to say what Mina protocol is. You are able to create zero-knowledge applications. The chain is succinct. You're able to verify it. And so if you're building products that touch private data, credentials, compliance, payments, all sorts of these things, we want to talk to me. We are more than happy to provide technical support, help walk you through the design considerations to build such a system. And we're looking for teams that are ready to ship and private, startups. We have grant programs. Like I said, we have teams that will give you technical support because this is a new field for probably a lot of people, and so we're here to help you and guide you through that. Very much interested in enterprises because this execution model is unlike traditional blockchain. And so I'm curious to talk to enterprises that are interested in sort of using the advantages of blockchain, but want to still keep their business private. So yeah, I'll be here after this talk, so please come to me and talk to me. And thank you for having me here. This is my hometown, so I'm very happy to be talking here. Yeah. Any questions? Anything ZK, non-ZK? Yeah. Go ahead.
You are providing solution. It is on-chain or off-chain where files are stored. Proofing.
Yeah, so if you're talking about ZK applications, those applications are run on your machine, and that's where it will be stored. The thing that will be stored on-chain is what you want to prove to the world, which is that statement and the proof that comes along with it. That's what gets onto the blockchain. Everything else is stored.
There are some universities who want their data tamper-free, and they want to store the documents on your solution. Is it feasible for them?
We don't store, ZK app, the data that you use to execute your zero-knowledge application is not stored on-chain.
Okay.
It's stored separately. That is the sort of whole idea about keeping your data with you itself. So there is some infrastructure that you may have to build. If it's personal, if it's just my ID, then that's just one file, so it probably doesn't make sense. But if you're building an enterprise, so it's an infrastructure you already probably have, and so you still continue to create that infrastructure for yourself, but then use blockchain for all the benefits of blockchain.
If we have multiple nodes.
Multiple nodes.
And we want to transfer that thing in that particular ecosystem, is your solution would work with that?
We can talk.
Because that is private blockchain. I think you are dealing with private blockchain, or you have developed your own different platform.
So Mina is a public blockchain.
Okay.
But when you write ZK apps, those are private. Those are off-chain. They're not on-chain.
Okay.
So if you have business logic and if you have applications that are running on blockchain, they probably are already public, or you may be running a private chain. So you are now able to have that same system, but then use public chain. And why? Because it helps in multi-party collaboration, makes it easier. Or there are other advantages, but you can kind of use it.
Is it possible for us to view the demo of how your blockchain is working?
Yeah, demo. Well, it's on mainnet, so you can see it. But I'm happy to show you. We have some documentation and all of that, and I can show you how it works.
Thank you, ma'am.
Yeah.
Hi, thank you. What major applications are you guys developing? And I also heard, Richard Hart, he's making DeFi application using ZK to as mimic exchange without proving your identity or KYC. So what do you have to say about that?
So for your first question is what applications. So we are the team that maintains the protocol, builds. We have O1.js, which is the SDK that you use to write ZK programs. So we're sort of like an infrastructure company, but in the ecosystem there are different projects that have built on Mina. So there's an L2 a roll-up that's built on Mina. It's called Zeko. There's a bridge to Ethereum that's being built. And so it's sort of in that infrastructure layer. What we did is build a POC of an application which is for image authenticity. So we built an application that using O1JS, you write a ZK application that proves that this image is real and not AI generated. So yeah, I don't think I got your second question.
The second question was like, I heard that this guy, Richard Hart, he's making a DeFi application using ZK.
Oh, the
where-
lighter team? Okay, go ahead, sorry.
No, so it's supposed to be like eliminating the middleman, and we can transfer all the coins and whatever
Yeah.
without doing the KYC. So is that what Zcash and something is like
Yeah,
similar?
yeah. So KYC, essentially what you do is you share all your identity information for someone to approve you for like some things, right? And you don't need to do that. KYC is like a perfect use case for ZK because you share what they need. They need that you're from India, then you just share that information. You don't share anything else. So yeah, so ZK is like a very apt technology to use for KYC and things like that. And using it for DeFi, it's even more applicable because you don't want your financial history splashed in front of the world. That's not what we've been doing with banks. So yeah, all of that is made possible now because ZK is accessible. Yeah.
Thank you.
So what kind of infra does it take to run a node and a validator on Mina? I heard you telling something about you can verify the proofs on your browser.
So right now, it's in the works. We are writing a Rust client, which then you can compile to WASM and then create a browser node. It's on DevNet. But generally, when you want to run a node on blockchain, you start from Genesis, download the entire history, get up to the latest state, and then start contributing. With Mina, you don't have to do that because it's a succinct chain. You get the latest few blocks, and you verify the proofs, which essentially is equivalent to verifying the entire history. So right now, you would use you would run it natively on your machine, but we are actually in the development phase of a browser node. You can look at some of our updates. It's on testnet right now.
And is there government interest, say from Europe, where privacy laws are very stringently applied, right? Is there interest from the governments to use a ZK proof instead of fetching customer data for KYC?
Yeah, I mean, few different companies use ZK to actually customize like their operations, like for example, voting and all of that, right? But generally, like it's picking up, I would say, because people are realizing the benefits of ZK. In fact, ZK actually was first mostly adopted by the blockchain industry, and it's in production, and there are billions of dollars kind of put on it. So it's kind of gaining more and more traction outside the blockchain as well. Like Google is invested, Apple, all of these people are kind of starting to use. So it's becoming more and more mainstream outside crypto as well. So we'll probably start seeing a lot of companies do that because of the GDPR law, it makes it so much more apt to use these models.
Does anyone else have a question? Okay. Yeah.
Have you heard about Brave browser? Like they use a decentralized advertisement model. So they also use ZK proofs there, like to deliver tokens, but they are not revealing who the person is, like who's searching around their browser. So how does that work in that case?
So there's a browser application.
They use the decentralized advertising model.
Digitized what?
Decentralized advertising model.
Advertising
So
points.
they give like Brave tokens to people for seeing ad. So I'm not revealing as a user my actual identity. Still, they understand, like they know who I am. So
Yeah, because I don't know how exactly it works, but if they're using ZK and it's on browser, then that computation probably happens with your information. But your information is not sent to them. Only that fact that they want to know is sent to them. So most businesses, you don't want to know your user's entire life history, or you don't want to know their entire identity. You just want to know some facts to make sure you're compliant with regulations, right? And so that's what it's probably doing, where it's running that application on your browser and only taking the data from your personal information and only sending the proofs. So that's why they don't know about you, but they know enough about you, which is maybe whatever it is.
Any
Okay,
any
cool.
last
Thank
question
you all.
taker?